All right, let's talk about measuring blood pressure. Unfortunately, this is something that we'd normally practice in a laboratory where I could demonstrate on a real person and you could practice on one another. But for our purposes now, I will just have to show you the bits and pieces and do my best to explain. Measuring blood pressure requires, or at least measuring by auscultation, which is the method, the traditional method of measuring blood pressure. Auscultation means to listen. So we're going to measure blood pressure by listening. It requires a blood pressure cuff, which you can see here. That cuff usually has really loud Velcro and wraps around the arm with a particular point. I don't know if you can see it. Arrows pointing to where you should have it lined up with the brachial artery, because this is the artery that we're measuring blood pressure with. This cuff is inflated and deflated using a bulb. The bulb has a valve, which if we turn clockwise, closes and will only inflate air. And when we want to allow the cuff to deflate, we open the valve and the air can come back through the tubing and leave the valve, deflating the cuff. The cuff is attached to this dial. This is called a sphygmomanometer. Say that 10 times fast. This is what actually measures the pressure. Now, does it measure the pressure directly in the brachial artery? No, because we don't have anything stuck in the brachial artery. It measures the pressure in the cuff. And then we're going to use another tool, the stethoscope, to listen for the pressure in the cuff when blood flow in the brachial artery is cut off, when it's restored, and when it's restored completely. Okay, so the pressure measurement is actually of the cuff, but the sounds tell us when the pressure in the brachial artery is greater than the pressure in the cuff and when the pressure in the brachial artery is lower than in the cuff. All right, so let's take a look at this scenario. When we measure blood pressure, the first thing we do is we inflate the cuff so that it completely closes off the brachial artery. Usually we go up to about 140 millimeters of mercury, sometimes higher. If you know that somebody already has high blood pressure, you'll go higher than that. But let's just say we go to 140. Well, and let's also say that in this example shown here, that the person has a blood pressure of 120/70, okay, for the sake of argument and illustration. So if I inflate the cuff to 140 millimeters of mercury, that's more pressure in the cuff than is in the artery, even when the ventricles are contracting. So no matter what, if I'm down here with the stethoscope listening, I'm not going to hear anything because there is no blood moving through the artery. As we reduce the pressure in the cuff, there will become a moment when the pressure in the cuff is lower than the systolic pressure in the arteries, but it's still higher than the diastolic pressure in the arteries. That means that only during systole is the pressure in the artery high enough to allow some blood through. But as soon as the ventricles relax, the pressure in the artery is no longer high enough to force its way past the pressure of the cuff. What this does is it allows little squirts of blood to come through each time there's a contraction of the heart. And so you'll hear the sound of the artery opening, the blood coming through, and the artery closing. The sound is actually from the turbulent flow of the blood. What you hear at the, um, what is this called? Elbow, where you have the stethoscope, is a tapping sound, a very light tapping sound. This is incredibly difficult to hear in a noisy room, so this lab is always difficult for that reason. You'll notice if you do the measuring blood pressure activities that I've posted on Blackboard that it's not always clear when that tapping sound starts, because it starts off quietly and becomes louder over a few heartbeats. And so knowing exactly when that tapping sound starts is a little bit art and a little bit science. So we heard that tapping sound start at 120, which means that the systolic pressure, so that the 120 we're reading off the sphygmomanometer, that's 120 in the cuff, and at 120 millimeters of mercury, it's letting some of the blood through, which means that at systole, the pressure in the artery must be 120 millimeters of mercury in order to overcome the pressure in the cuff. So, as soon as you hear the tapping sound, you look at the sphygmomanometer, record the number, and that's the systolic pressure. Now, as we continue to reduce the pressure in the cuff, there will come a moment when even the diastolic pressure, or the pressure when the ventricles are resting, is high enough to push back or stay open despite the pressure in the cuff. Now, if we're listening at this moment for those sounds, we're not going to hear anything because there's no squirting of the blood going through. In fact, there's steady flow, and steady flow does not make an interesting noise. So as soon as the sound stops, that means that we've reached the diastolic pressure. And you look at the dial, the sphygmomanometer, and see what number is there, and it gives you the diastolic pressure. Just like with systolic pressure, this is not a clear-cut thing. It starts to get quieter, and sometimes it's hard to know when that tapping sound stops exactly. But this person's pressure would be 120 over 70 because we heard the sounds start at 120 and stop at 70. By the way, these sounds are called Korotkov sounds, named for the scientist who described their origin and how to use them to measure blood pressure. There's Korotkov. Here's another diagram that helps to illustrate what's happening. This line shows the pressure in the brachial artery as the ventricle contracts and the ventricle relaxes. Ventricle contracts and relaxes. This line represents the pressure in the cuff, which we've inflated to above systolic pressure to start with, and we allow to slowly deflate. When the moment comes that the systolic pressure in the brachial artery is higher than the pressure in the cuff, that allows the first little bit of blood through and produces the first Korotkov sound. And this tells us what the systolic pressure is. So as soon as I hear this first sound, I look at the dial, or in this case the graph, and I say, oh, it's at 120. I keep letting the cuff deflate here. The sounds continue, again, only allowing blood through each time that the pressure in the artery is higher than the pressure in the cuff. At some point, the cuff is deflated so that the pressure in the artery is always high enough to pass through the artery, and the sounds stop. Now, in the lab, we would use software to help learn how to measure blood pressure and to be able to see it in practice. What this would look like is this. Now, this is not blood pressure yet. This is what it looks like to inflate the pressure in the cuff. We're not listening for anything in this graph at all. I just want you to see what it looks like. So pressure, you can see with each pump, the pressure in the cuff increases. And then we slowly deflate the cuff and the pressure decreases. If we listen to this, in this case with a cardio microphone so that we can record it on the computer, as opposed to with a stethoscope, this is what it looks like. So here's the pressure in the cuff, slowly deflating, slowly decreasing. And these are the sounds that are picked up by the cardio microphone. You'll notice that all of a sudden these lines appear. These are the sounds that the microphone is picking up. Now, do I look at this one? Is that the first one? Is that the first one? This is where it's art as much as science. And when I look at the last one, is that the last one? Or is that the last one? So this is something that or one of the reasons why we take multiple readings of blood pressure whenever we do read someone's blood pressure, so that we can be sure that we have an accurate measurement. We kind of take the average of those measurements. So let's say that this is the first sound. So if I hear the first sound, then I want to know what is the pressure in the cuff, because that tells me the pressure in the artery. So I'm going to go up here to cuff pressure and then go over here to look at what the pressure in the cuff is, and it's about 110. The computer tells me 107. Now, so that's our systolic pressure. Now, if I go over here to when the sounds end, so let's say this is where the sounds end, I'm going to go up, look at the pressure in the graph, follow that to where I can read the numbers, and that's at about 75. So the diastolic pressure is 75 millimeters of mercury. So this person has a blood pressure approximately of 110 over 75. And this gives you more of a visual in terms of how blood pressure is measured.